Hello all. Today we'll be discussing some of the problems of unit hydrograph. We start with the simplest problem and then go to a little complex problem. So the first problem is how to derive a unit hydrograph from a given discharge and base flow data. Generally, most of the problems are in tabular column and you have to calculate values in the tabular column. A figure gives a good representation, but it is not mandatory. Now, in your discharge, your total discharge is basically your stream flow, the flow, total flow. In that, the base flow is a delayed flow after a rainfall event. Whereas your direct runoff is the immediate flow which happens on the ground due to a rainfall event. So for finding the units, the ordinates of a unit hydrograph, now this first problem, the time is given, total discharge is given, and the base flow details is given. Now to get the direct runoff, we deduct base flow from total discharge. So 14 minus 14, 0, 25 minus 12, 13, 51 minus 11, 40, and so on. Then we add up all these ordinates to get the sum, that is 166. Now this is useful to calculate my unit hydrograph. Now we have a formula, direct runoff is equal to total volume of direct runoff divided by area of basin. This direct runoff is in centimeter or millimeter depending on the units which is given. So then we have the further formula that is equal to 0.36 into sum of ordinates into time 3 divided by your area. Again, I substitute 0.36 into sum of ordinates. I get it as 166 into 3. Your 3 is a time interval here. So your time interval is 3. 0 to 3, 3 to 6, 6 to 9. The time interval is 3. Divided by 30, the area of the basin is already given. We will be getting the value of 5.976 centimeter. Now to get the unit hydrograph ordinates, direct runoff divided by 5.976, I'll be getting the ordinates of your unit hydrograph. So this is the first simple problem. Now the second problem is your unit hydrographs are given. From there, you have to derive your direct runoff hydrograph. Okay. Now here the ordinates of a 6-hour unit hydrograph is given. Okay. The time is given for every 3 hours. The ordinates is given. And we have to calculate the direct runoff hydrograph for every 6 hours. Okay. So here it's a simple problem. If the rainfall excess, here it is given as 3.5. What you have to do is you just have to multiply the ordinates into 3.5. 0 into 3.5, I'll be getting 0. 25 into 3.5, I'll be getting 87.5. 50 into 3.5, 175. So this from the unit hydrograph, if I multiply into the rainfall excess or the effective rainfall, I'll be getting your direct runoff hydrograph. Okay. Now in this case, it is important that the rainfall excess also happens in the same hour duration. If a unit hydrograph is 6 hour, when I say 6 hour unit hydrograph, 1 centimeter or millimeter of rainfall excess has happened for 6 hours. Okay, so when I'm finding my direct runoff hydrograph, that time period of the rainfall excess or rainfall excess or effective rainfall also should happen for 6 hours. Otherwise, if it is not so, you can't do it directly. There is some other method. So here 6 hour unit hydrograph, your rainfall excess of 3.5 is also occurred for 6 hours. So you just have to multiply with 3.5. So this will give my result. So this is a simple graph showing the 6 hour unit hydrograph in blue and the direct runoff hydrograph in your red. Coming to the next problem. Now here a 6 hour unit hydrograph ordinates is given. The interval is every 3 hours. Now there are 2 storms. Okay, 2 storms. Rainfall excess 3 centimeter and 2 centimeter are occurring. Okay, And both are occurring for 6 hours, they have told over here. And they're telling that calculate the ordinates of the direct runoff hydrograph due to the rainfall excess of 3 centimeter followed by 2 centimeter occurring in 6 hours. So here both the rainfall excess 3 centimeter is occurring for 6 hours, and after that 2 centimeter is occurring for 6 hours. So your ordinates are given. This is a 6-hour unit hydrograph. The ordinates are given here. So how to go about? Now here in this case, since two events are there, it is better that you have uniform time interval. So here you can see in the beginning is 0, 3, 6, 9, 12, 15, 18, 24. In between now the data is missing. It would be advisable if you're a newcomer to fill in the data before you do the analysis. So here after 18, 24 value was not there. I added 24 in between, and the corresponding unit hydrograph I got by taking the average of the data below and above. Similarly, 27 was not there. I took the average of the above and below. I got 135. If you are a beginner, it is advisable that you get the average. If you are familiar with the problems, you can know how to go about. Now, first is your 3 centimeter of rainfall excess. So I'll write the coordinates for 3 centimeter of rainfall excess. So that is called as your direct runoff hydrograph for 3 centimeter. So all you have to do is unit hydrograph into 3, 0, 25 into 3, 75, 50 into 3, 150. Till the end you have to do. Till the end you have to do. And the next one is your direct runoff hydrograph for 2 centimeter. So first we'll just calculate it, then I'll tell you what has to be done. So first I'm just calculating 0 into 2, 0, 25 into 2, 50, 50 into 200. So I've calculated all the ordinates till the end. Now remember that this 2 centimeter is happening after 6 hours. So first 6 hours is for 3 centimeter of rainfall. It is starting after 6 hours. So what I'll be doing, I'll be lagging this by 6 hours. So this 0, I'll be starting at 6. Okay, I'll be lagging it by from 6. So from 0, no, it is not starting from 0. It is starting from 6 hours. So I'll lag it here and fill in the values. And then all you have to do is add this value and this value. You'll be getting the final value. So here 0 plus 0 is equal to 0. 75 plus 0 is equal to 75. 150 plus 0 is equal to 150. 255 plus 50 is equal to 305. Be careful while adding. If you want, you can make a cross when you're doing the problem so that by mistake you don't add these values. I have given a dark blue color so that I avoid taking the value. In your notebooks, you can just cut this value so that you can take the correct values for the problem. So this is a problem where 2 rainfall excess events are given. Coming to the next problem, here the previous problem they asked you to calculate the direct runoff hydrograph. Here they are asking you to derive the flood hydrograph. Your flood hydrograph and storm hydrograph are the same. Along with your direct runoff hydrograph, it includes your base flow. That time, when you include your base flow, the hydrograph what we are getting is called as your flood hydrograph or your storm hydrograph. Now here in this data, there are a lot more data given. So here the accumulated rainfall data is given. So from 0 to 6 hours, the total accumulated is 3.5. From 6 to 12 hours, the total accumulated rainfall is 11. Then 12 to 18, accumulated is 16.5. And the little more details, I'll just read out. The ordinates of 6-hour unit hydrograph is given. So these are the ordinates, it is given. The storm loss, that is a Phi index for the catchment, is estimated to be 0.25 centimeter per hour. Okay. The base flow is equal to 15 meter cube per second at the beginning and increasing by 2 meter cube per second for every 12 hours till the end of direct runoff hydrograph. Derive the flood hydrograph. So whenever they ask you to derive the flood hydrograph or storm hydrograph, you should include the base flow. If they ask you to calculate only direct runoff hydrograph, you just have to multiply your unit hydrograph into the rainfall axis and do the calculation as we did in the previous problem. So, okay, so these are the ordinates given. Now, again, remember, see here, 6-hour unit hydrograph, the time interval is also 6. This is important. Now, first, so accumulated rainfall is given. Now, from the accumulated rainfall, I'll be calculating the rainfall for that duration. So, from 0 to 6, it is 3.5 itself. From 6 to 12, the accumulated was 11. I want only for doing that time. So 11 minus 3.5, 7.5. And again, 12 to 18, the accumulated from the beginning, it was 16.5. So I want only for that time, that is 16.5 minus 11. Now, after this, you have your Phi Index. Your Phi Index is basically your initial loss, your infiltration. When rainfall is occurring, a part of the water infiltrates to the ground. So that has to be deducted. So they have told it is 0.25 centimeter per hour. So if it is per hour, my duration of the rainfall is 6 hours. So I'll be multiplying 0.25 into 6, I'll be getting 1.5. Okay, since the rainfall for each is occurring for 6 hours, I'm multiplying into 6. And finally, the effective rainfall will be your rainfall minus your infiltration. So here it will be 3.5 minus 1.5, 2. 7.5 minus 1.5, 6. 5.5 minus 1.5, 4. Now then, we'll do the same way. First is my 2. So these are the data given. Here again, there was missing values. So I have taken the average, taking the above and previous and the next value. I have taken the average. Now first is for 2 centimeter effective rainfall. So I'll multiply all the ordinates into 2. 25 into 250, 50 into 200. I'll be multiplying. Then is my 6. So 6, I'll be calculating the ordinates and then I'll lag it by 6 hours. So here 6 is starting, I'll be starting with 6. So all these ordinates, I have delayed it by 6. So here is 6, delayed it by 6 because it is starting only after 6 hours. Similarly, the same thing I'll be doing. I'll be calculating for 4 effective rainfall by multiplying the unit hydrograph into 4. And I'll be delaying it by 12 hours. Okay, 12 hours. Because first is 2, then it is 6, and then it is 4. So 12 hour means where is my 12? From here, I'll be delaying. So when you're doing the problem, as I told you, you can cut the value so that you are not adding the wrong values. Now here, along with the direct runoff hydrograph, they've asked you to calculate your storm hydrograph. So whenever storm hydrograph is told, storm or flood hydrograph is told, you have to add the base flow. The base flow value is given as 15. And they have told that it increases by 2 meter cube per second after every 12 hours. So here, starting it is 15, 15, 15, 15. Then at 12th hour, it is increasing by 2. It becomes 17. So 17, 17, 17, 17. At 24, it increases to 19. So I've shown by the change in color what is the increase of your base flow. And finally, add all these values. So here adding will be 0 plus 0 plus 0 plus 15 is equal to 15. I'll take some value here. This one, I'll be getting 250 plus 300 plus 0 plus 17, I'll be getting 567. So this is how we do the problem, okay, where storm hydrograph is being asked. I've drawn the graph also for better understanding. Now, after this, we'll come across to convert one type of hydrograph to other type of hydrograph. So I'll first start with the conventional method and then I'll explain you the trial and error method. Okay, the conventional method is easier. Trial and error method requires a lot more understanding, a little more understanding. So here I'm converting a 4-hour unit hydrograph to 12-hour unit hydrograph using S-curve method. Now, when I say 4-hour unit hydrograph, my 1 centimeter of rainfall is occurring for 4 hours. When I'm converting to 12-hour unit hydrograph, that same 1 centimeter is happening for 12 hours. So generally, when we have an increase in time, my graph will actually come down because 1 centimeter is constant, rainfall exists. One is for 4-hour duration, the other is for 12-hour duration. So here I'm converting 4 to 12. So the ordinates are given for every 4 hours, the ordinates are given. I have taken down the ordinates. I'm taking it down again. The time is given for every 4 hours. And this is your 4-hour unit hydrograph. Now the next column I'll have is S-curve addition. Okay. And the next column is S-curve. Okay. Now how I'll fill it is first 0 plus 0 is equal to 0. This value, I'll take it down to your S-curve addition, to the next row. I'll transfer this value 0. Then again, 20 plus 0 is equal to 20. I'll take it down to the next row, diagonally down to the next row, 20. Again, 80 plus 20 is equal to 100. This 100, I'll diagonally take it down, 100. So similarly, I'll be calculating till the end. And as you see, as you reach the end, the values becomes constant. Okay, most of the time, the last 2-3 values become almost constant. So this is my S curve. Your S curve is accumulation of all values. If you draw the graph, not drawn the graph here, there's one more problem where I've drawn the graph. It's accumulation of all values. Now, after this, what you're supposed to do, since we are converting 4 to 12, I'll be lagging the S-curve by 12 hours. So this is the S-curve ordinates. The same thing I'll copy, but I'll be lagging it by 12 hours. So here is 12. I'll be taking all these ordinates, lag it by 12 hours. And then what I'll do, I'll find the difference between S-curve minus S-curve lag by 12 hours. Okay, and why I'm lagging it to 12 hours? Because I'm converting 4 to 12. So minus. So 20 minus 0, 20. 100 minus 0, 100. 230 minus 0, 230. Then from here, 380 minus 20 is equal to 360. So I'll be finding the difference between S-curve minus S-curve lag by 12 hours. So I'll be getting these ordinates. Then after that, to get my 12-hour unit hydrograph, what I'm supposed to do? I have to take this ordinate, 0, divided by 12, what I'm converting to, into what data I have got. So divided by 12 into 4. So 20 divided by 12 into 4, I'll be getting 6.6667. Okay. So remember, you remember one. You are converting 4 to 12. You have to multiply into 4 divided by 12. If I'm converting 2 to 4, I have to multiply into 2 divided by 4. So similarly here, I'm converting 4 to 12, multiply by 4, divide by 12. So I'll be getting these ordinate values. Okay. So this is your S-curve method to convert one hydrograph to another. I can do the same thing other way around also. Here we did from 4 to 12. The next problem deals with 4 to 2. Okay. Now for using this method, the only condition is that now if I take 4 to 12, my time interval should be the minimum of these two, that is 4. Okay. From 4 to 12, the minimum of the value. So 4 is a minimum. The interval also should be 4. Now coming to the next problem, what we were doing, we are converting 4 to 2. So my minimum of 4 and 2 is 2. Okay. So 2, I have to add the values. Since the data is not given, since the data is not given, I have to add the values in between. Otherwise, I won't get an accurate value. Okay. So if I'm converting 4-hour unit hydrograph to 2-hour unit hydrograph, now if suppose if it is given for every 4 hours, I have to have the values for 2. You can do it by averaging the values. Okay. And again do the same thing. So here, so you have got for every 2 hours. So same way, S-curve addition, time, 4-hour unit hydrograph, S-curve addition, S-curve. So here 0 plus 0 is equal to 0 to the next diagonal column. 8 plus 0 is equal to 8. Take it down. 20 plus 8, 28. Okay. Then S-curve lag by 2 hours. Okay. I'm lagging it by 2 hours. So 2 is next. Then I'm finding the difference. 0 minus 0, 0, 8 minus 0, 8. And then again, and then what I'm doing, as I told you, I'm converting 4 to 2. So multiply by 4 divided by 2, I'll be getting the ordinates of your 2-hour unit hydrograph. Okay. So this is how we do your conversion, use of S-curve method. Now here you're using the S-curve addition method. We have something called as a trial and error method. Now for the trial and error method, generally all the values should be given, all the R, 0, 1, 2, 3, 4, 5, 6, 7, 8, all the time. Only then your trial and error method can be good. Okay. Whereas your S-curve method, as I told you, if suppose I'm converting 4 to 12, minimum of this, the time interval should be minimum. If I'm converting 4 to 2, minimum of this, the time interval should be minimum. If it is not there, you have to include the value. For this method, by trial and error method, you need to have all the values. Only then it will work out correctly. Otherwise, your trial and error does not work out correctly. So I'm converting here 2-hour unit hydrograph to 6-hour unit hydrograph. So what I'm doing, I am taking down all these values. Okay. Then the next column, I am lagging it by 2 hours. Okay. 2-hour hydrograph lag by 2 hours. Then again, the same this, I am lagging it by 4 hours. So I'm starting at 2 here. I've just copied this value, lagged it by 2, lagged it by 4. In the corner, you should have one column where you're adding all these ordinates. Okay. And you should continue this trial and error till you get almost constant value below. So till then, you have to keep on adding. Okay. So when you do manually, it takes a lot more time. Generally, you won't give this in your exam. It takes a lot more time where you're actually seeing, adding all these values. Okay. Adding. So I have done 2, 4. When I add up, you won't get a constant value. You have to go a little more further. So in doing it in paper, it takes a little more time. You have to continue this till you get almost constant value here. Till then, you have to keep on lagging. Okay. You get the S-curve ordinates. And then again, same thing. I'm converting 2-hour to 6-hour. So 2-hour S-curve I have got. Lag it by 6 hours. I have lagged it by 6 hours. You find the difference between the two. And then as I told you, what you're supposed to do, 2 to 4 multiply by 2 into 6. I'll be getting the values of your 6-hour unit hydrograph. Okay. 6-hour unit hydrograph. So only the first method is, instead of your S-curve addition, you're using your trial and error method. Now, in case you want to do it by the conventional method, S-curve addition method, first thing what you have to do is you have to remove the values in between. I don't want the value of time R1, 3, 5, etc. So I've done that also. Okay. So I have to remove those values because from 2 to 4, sorry, 2 to 6 here it is. I should have only the minimum time interval is for every 2 hours. So I've taken the 2 hours. I'm using the S-curve addition. Difference, I'll be getting the 6 hours. Okay. So when you do the method, look at the data given. Always go for S-curve addition. But for S-curve addition, I told you, whatever you're converting, the minimum of that you should have. And your S-curve addition does not work well if I'm converting 2 to 3, okay, or 2 to 5. You need to go by the trial and error method where all the time intervals are given. 0, 1, 2, 3, 4, 5, 6, everything is given. Now coming to the last problem, this problem I had given in your internal test. So here again, you're having 3 rainfall events, okay? And then here again, they are having an infiltration index and a base flow. And they've asked you the flood hydrograph or your storm hydrograph. So you have to add your base flow. So here the rainfall events are, so the rainfall event is happening for 3 hours. The first is 3, 4.5, 1.5, doing subsequent 3-hour interval. Okay. So 3-hour unit hydrograph, this also should be 3. Now assume an initial loss of 5 mm. Now before I go for 5 mm, I'll deduct the infiltration index and then calculate. So here I've calculated. So for 0 to 3, 3 centimeter, 3 to 6, this is not cumulative, only from 3 to 6, it is 4.5, 6 to 9, it is 1.5. Now here the infiltration index is 5 mm per hour. Okay, so that is 0.5 centimeter per hour. So since it's 3, it will become 0.5 into 3, 1.5, 1.5, 1.5. Okay. So rainfall minus infiltration, I'll be getting the effective rainfall. So 3 minus 1.5, 1.5, 4.5 minus 1.5, 3, 1.5 minus 1.5, 0. So the last event is not there. You don't have to even calculate that. Now here they've asked, assume an initial loss of 5 mm. This problem I have taken from the VTU, this itself. Now remember, initial loss of 5 mm or 0.5 centimeter, you have to deduct it here. But since you're already getting a 0, you can't have a negative value. I have not deducted it. But if you're not getting a 0, you have to have one more column saying initial loss is 0.5 centimeter. So it'll come. Okay, I'll just write it here, 0.5. So your rainfall will be 3 minus 1.5 minus 0.5. That will be equal to 1. Okay, but I have not used it here because already for the third rainfall event, I got 0. Your rainfall event can't be negative. Okay, it can only be 0. I have not considered it. So in your problem, if suppose you're not getting 0 in your effective value, you have to again deduct the initial loss if asked. See here the unit is mm, you have to convert to centimeter and do the same procedure as we did earlier. Okay, so here for the third event, it is 0. So you don't even have to calculate it because the entire value is 0. Only for 1.5, 3 centimeter, I have dragged it by 3 centimeter. And then I have added the base flow. With this, I'll be getting the storm hydrograph or your flood hydrograph. So these are some of the problems of your unit hydrograph. Thanks for listening.